All right, let's talk about carbon dioxide. It's the gas we breathe out, it's the bubbles in your soda, and it's also the molecule right at the center of the biggest debate on our planet. So let's just get right into it and try to unpack the incredibly complicated story of CO2.
So, what is the deal with this stuff? Is it a hero, the thing that makes life on Earth even possible? Or is it the villain, the one pushing us towards a climate disaster? Well, as you're about to see, the answer is, well, it's not simple. Not at all. I mean, think about it. On one hand, without CO2, without that natural greenhouse blanket it creates, our planet would just be a frozen rock. We're talking something like 33 degrees Celsius colder. Yikes. But, and this is the big but, we've basically supercharged that blanket. And that right there is where all the trouble starts. Okay, to really get a grip on what's happening, we've got to look at the numbers. And trust me, the story these numbers tell, it's all about some seriously dramatic, unprecedented change. So check this out. For pretty much all of human history, right up until the Industrial Revolution kicked off, the amount of CO2 in the air was just stable. It hovered right around 280 parts per million. So what does that mean? It means for every million bits of air, 280 of them were CO2. That was the planet's natural balance, the status quo. And here's where we are today. We're sitting at roughly 424 parts per million. Look, that jump from 280 to 424, that is not a small bump. This is a massive, fundamental shift in the actual chemistry of our atmosphere. And here's the thing that's really crucial to understand. It's not just that the level is higher. We're talking over a 50% increase. It's the speed. This is by far the fastest our planet's CO2 has risen in millions, and I mean millions of years. So naturally, this insane spike has created two totally different stories about CO2. So let's do this. Let's break down both sides of the argument, CO2 the savior and CO2 the villain.
Okay, this really frames the whole debate perfectly, doesn't it? On one side, you've got the savior argument. CO2 is essential for life. It's basically plant food. Then on the other side, you have the villain case. It traps way too much heat, it's driving crazy weather, and it's messing up our oceans. Let's dig into each of these, and we'll start with the case for CO2 as a savior.
All right, so let's start with that savior argument. NASA's satellites have actually found something pretty remarkable, a global greening effect. The planet is literally getting greener. And the reason why? Well, it's pretty clear. A whopping 70% of this extra leaf cover is coming directly from what's called CO2 fertilization. Yeah, it's a really simple idea, but it's also super powerful. You put more CO2 in the air, and it literally acts like an airborne fertilizer. It just boosts photosynthesis and helps plants grow bigger and faster. It's plant food. Okay, but now let's flip the coin over and look at the villain case. And this whole argument is really just grounded in basic physics. CO2 traps heat. Simple as that. It's like we keep throwing a thicker and thicker blanket over the Earth. And the IPCC, that's the Intergovernmental Panel on Climate Change, they estimate that for every time we double the amount of CO2, we get about 3 degrees Celsius of warming. And that is what intensifies heat waves, storms, and causes sea levels to rise. But of course, the story gets even more complicated. You know that greening effect we were just talking about? Well, it turns out there's no such thing as a free lunch. It comes with some really serious hidden costs. And here's the big catch. Well, yeah, the plants might be getting bigger in this high CO2 world. They're also becoming way less nutritious. I love this analogy. It's like they're bulking up on junk food. You get more stuff. But as you can see from that drop in the nutrient levels, you're getting a lot less of the good stuff.
And we're not talking about a small change here. Studies are showing that the staple crops that billions of people rely on, things like rice and wheat, are losing significant amounts of protein, zinc, and other critical nutrients. This has absolutely massive implications for global food security.
But the hidden costs don't stop on land. See, the oceans absorb about a third of all the CO2 we pump out. And when that happens, it triggers a chemical reaction, a process called ocean acidification. And scientists have a pretty chilling nickname for this too. They call it climate change's evil twin. And honestly, when you hear that, you know it's got to be serious.
So to put that into perspective for you, our oceans could become about 150% more acidic by 2100. And what that does is it makes it incredibly difficult for organisms like coral, oysters, and even plankton, the absolute base of the entire marine food web,
to build their shells and skeletons. This threatens, well, entire ecosystems. So, with such high stakes, what do we do? How do we move forward? It seems like the key is to find some kind of balanced path, one that avoids both total denial on one side and paralyzing panic on the other.
Well, one of the leading solutions that economists talk about is something called carbon pricing. The idea is really simple. You make pollution cost money. By putting a price tag on carbon, you force the market to actually account for the true cost of emissions. And that creates a really powerful reason for companies to innovate, to invest in cleaner tech, and to find a way to balance economic growth with protecting the climate.
But just cutting emissions, that's only half the battle. We also have to focus on two other huge priorities. First up is adaptation. Look, some warming is already baked in. It's inevitable. So we have to plan for it by building stronger infrastructure and developing crops that can handle the heat. And second, there's equity. We have to make sure that whatever policies we come up with actually support the most vulnerable communities, the ones who are hit hardest by climate change but have done the least to cause it.
This really lays out the different ways of thinking about it. At one end of the spectrum, you have denial, which frankly just isn't supported by the data. On the complete other end, you've got extreme alarmism, which can actually backfire because it ignores our ability to adapt and innovate. That path in the middle, climate realism, is all about saying, okay, the risks are real and they are serious, so let's focus on practical solutions that actually work. You know, this might be the perfect way to think about it. Imagine CO₂ is like salt in a recipe. You absolutely need some. It's essential. But we've gone and dumped the whole shaker in. We've added way, way too much, and now the whole dish is in danger of being ruined.
So at the end of the day, CO₂ itself isn't the monster here. It's just a molecule. It's more like a really powerful lever. And the final outcome, whether we end up with a feast or a famine, a flourishing planet or a struggling one, that all comes down to how we as a species decide to manage that lever. So let's just leave it with this thought. Maybe the whole debate shouldn't be about whether CO₂ is good or bad. That's kind of missing the point. The real question, the one that matters for every single one of us, is this. Now that we know we've messed up the recipe, how are we going to fix it?